Hello, welcome back to Design a Computer from Scratch. This is what we're calling Appendix A3, and let's make some serious improvements to the assembler. Currently, the assembler is dependent on external files, which are imported at the beginning with a hard-coded path. Let's make it so others can run it by including those common folders or common files, imports, into the same GitHub as the assembler itself. If you double click on the PyAssemble, it will now run, or after we're done with this, it'll run from the same folder without having to go try to find those other dependencies. It's hard to see this when you're running something on your own. You forget about the dependencies. So if you tried to run it, I apologize for that, but now it should run without any problems. Also, while we're here, while we're playing with the assembler, let's add some pseudo instructions. That'll allow us to expand the instruction set without tying up opcodes. Currently, our instruction set has 10 opcodes. That leaves 6 free opcode values for future expansion, and it would be nice to not tie up things that can be done in the assembler. What sort of thing can be done in the assembler, you ask? Well, currently the NoOp works by using an unimplemented instruction, and that's done in the assembler at the moment by coding a NoOp as a 0, 0, or 0 in the opcode field, those 4 bits that determine the opcode. And that would essentially tie up one of the opcodes, which leaves only 5 free opcodes. It would be nice to free that. So let's go take a look at how to do that. I think I hinted at this in a past video, but there are operations that are safe. Like if you OR register 8 with 0, or actually if you OR any register with 0, you're going to get back that register, so it's a non-destructive operation. It would just click off the 4 steps of the gray code counter and not perform any actual operation on a register or on memory or on peripherals or anything like that. So in this case it's doubly safe because register 8 we've defined as a constant value of byte of 0. And an OR of 0 anyway wouldn't do anything even if it could. So this could be done in the assembler, and that would allow the source code itself to have a NoOp. That's why we're calling it a PseudoNoOp, but it would be coded by the assembler in the translation to the MIF file and the listing file, but it would be translated by the assembler in the MIF file as a OR register 8 with 0. And if we do it right, it'll still show a NoOp in the listing file. So we won't have affected the way the listing looks. If you look through the signal tab instructions, it'll show that OR of register 8 with 0, 0, and it'll just look a little strange. But the listing file will be fine, and the operation will be as if we'd written a NoOp instruction. So the current encoding inside the Python assembler is to encode it as all zeros. All we have to do to change that is to change that current encoding to a 0x9800, which will encode it as an OR immediate register 8 with 0. And that produces the desired result. Before it was the second line there, the NoOp was a 0x000, now it's a 9800 hex. So it did that implementation. That was a pretty easy change, a single line of the assembler to add a pseudo-op, or add the several lines to say if it's a NoOp, do that. Well, in this case that was already there, it just changes the encoding. So good change and worth doing. Let's do a little bit more in the assembler. We could add another pseudo-op that we might do. One of the sorts of things you do frequently is call branch to yourself or jump to yourself. So we could add an HLT instruction, which would be a halt. There's a couple of complications with this. Halt could be anywhere in the code, so the jump would be to the line you're on. So it'll have to keep track of the line you're on. And you could have multiple halts, so we need to have different labels for that. So let's use the address as part of the label itself internally. It doesn't show up externally, but it would be an internal use. So the halt is a jump to self, and the implementation would be label being halt, op being, or the mnemonic for the operation being jump and the label being halt, but we don't want to have to type that out every time or keep track of it. Let's internally reserved label is h underscore the address. Unlikely to use that, but it would be a reserved label now. Actually, we could check the source file to see if there are any h underscores with numbers in it, but we'll just keep in track in our mind that that's not something we can do. And it will add a pseudo opcode halt, and that will also be done in the assembler, just like the NoOp was. So the assembly code for that would look like, here's an example with the NoOp and a halt. The first NoOp, of course, got re-encoded as a 9800 or immediate register 8 with 0, and the second line got turned into a jump. It still shows up as HLT in the opcode listing file, so we know we created a halt, but the encoding is E001, which is the address of that line for self, so it is implemented as a jump to self. So that was another easy low-hanging fruit to add. Other pseudoops could be added if there's something you want to do that you would rather have another opcode, another mnemonic for, but it wouldn't have any effect on the opcodes, and you can replace it with one or hey, even more if you had a common operation. That would be sort of a compiler at that point almost. The list of pseudoops we currently have are that NoOp, which encodes here, as shown here, as a 9800, and the halt, which encodes as an E and then the address of the line that does it. The other thing I'd like to fix while I'm in the assembler is it currently has external dependencies to 3, and actually even more. I think it has 4 because one of these calls another import. And those are off in another of my GitHub folders. So if you tried to run the assembler, you probably got something complaining about not having those imports. And we can easily fix that just by adding those into the same folder that the assembler is in, and then removing the syspath append. So it's very specific to my computer right now, but we could make it generic so it would run on anybody's computer. All you have to do is reload the project and grab those use those other import files. So that did resolve the external dependencies. Now it can be run without hunting the externals down. I know because if I got rid of the sys line there, that syspath append, that it had to have pulled it all out of the current folder and made sure that everything was in there. There's an additional one that checks to see if the file has been updated, a clean check, and that one also was added to the list. You can ignore those. You don't run those when you run the program. They are called by the assembler, so you just do the pyassemble to run it. Those, like I said, those external dependencies are now removed, and if you want to try running this stuff, all you need is Python 3, and you should be able to double-click on it and have it run. So we also added the two pseudo-ops, or mnemonics for these pseudo operations, and the NoOp and halt. And in doing that, we set a pattern for implementing other pseudo-ops that you might want to do in the assembler. The beauty of all this is none of this affected the CPU VHDL code. It still runs exactly like it did. I would certainly welcome it if somebody wanted to create a assembler that did not require Python 3. I think that would be a helpful thing to have, a Java script or something else like that. As I said earlier on, I think it could all be done in Excel. It would through VLOOKUPs and other sorts of things. That would probably be a fairly simple task to do. The file is tightly constrained, so it should be easy to pick off positions to grab stuff from and generate what needs to be generated. Didn't go down that path because Python's just very comfortable for me. I created a GitHub branch for that particular change. Of course, the tip itself has it if you just want to grab those files out of the folder that has the assembler in it. You can grab them from there. If you're playing with an earlier version, if you want to grab the current version, which includes everything done to date. That would be here at the tip, the design a CPU spot. But if you just want this, if you want to play at this branch, it's the app3 branch. Thanks for watching the video. I appreciate it, and I hope you are playing with the designing your own CPU. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.